My chronometer tells me it's past 2 o'clock, so I think we should get started. All right. Well, here we go. I have some slides. The slides are out on Blackboard if you want to have a copy, or you can just throw them out so you can see what I'm going to say. They're exactly what I have here. I haven't edited a bit because I didn't have time. They were, you can see they were put out there just minutes ago. But okay, let's get going. All right, there we are. Okay, following the textbook, we're going to talk about reconnaissance today. You may notice if you actually look at the schedule on the syllabus, we're a little bit ahead or behind. Don't worry, we'll figure it out later on. All right, because I'm an old guy, we're going to start talking about what happened before the web. Yes, folks, the world existed before the web. Long before the web started, there was the internet. The internet's been around since the early 70s. And shortly after they created the internet, they invented email. And so people were sending email across the web. That was the big use of the internet at that time, transferring files and emails. And then people started doing things to transfer information. They had bulletin boards, which was sort of like the idea of the web, where you could have data and go out there and look at it and get information. Although it didn't have any pictures. It's kind of dull. I mean, you could have pictures, you could download a picture, but it wasn't part of it. It was not a graphical interface. It was a text-oriented interface. At that time, there was the Gopher protocol. That was very popular. So you had a lot of Gopher bulletin boards. The character we have here is the University of Minnesota Gopher logo. That's because Gopher was created at the University of Minnesota. And having graduated from the University of Minnesota, I can tell you that's not really a gopher. That's a 13-line ground squirrel. They just call it a gopher, because the golden 13-line ground squirrels just doesn't come off the tongue very well. Okay, then Tim Berners-Lee created the web at CERN. Did I say when that was? Yes, back in '91. So it's quite a while ago. He created HTTP and HTML, and that made the web work back in '91. In the beginning, there were static web pages. That is, you created a web page in HTML, loaded it on a file in a server, and then as you clicked on a link or typed in the URL, it would download that file and display it on the screen. Server-side programs might generate information, but basically you loaded pages and that's what you saw. There was no execution on the client side. It merely displayed the information. Now we have distributed applications. The web pages involve programs, typically JavaScript or other languages, and they run there. They can, you download the page, they can go out and get further information from the server and display it. So you can get data and display it on the screen without refreshing the page. Originally, you just have to go to a new web page and display the information. That is, refresh the whole page. Okay, I got a question here for you folks. If I can find the poll. Well, Zoom fails me. Okay. Well, instead of doing the poll, I'll simply ask everybody right now, and we can do this live. How is WebGoat going? Has everybody got WebGoat installed? I was going to ask the question whether everybody has it installed or having problems. Is this pretty much successful?
Yeah.
Yes.
Yep.
I hear a lot of yeses. That's good.
Yeah, yes, on Linux at least.
On Linux. Okay, yeah, it works in many places. Oh, yeah, if my chat was working, I would. Yeah, so I guess if you're having problems, send me an email or text me or something. So let me know that it isn't quite working, and we will work together to get it fixed, because you need WebGoat. In fact, at the very end of this lecture, I've got an assignment that uses WebGoat. So you're going to need to have it working. All right. So glad to hear that. Moving forward, maybe. Okay. Let's talk about web applications. You probably know more about web applications than I do, because I'm not a web developer. I'm just this old college professor that teaches about web development. Actually, I don't teach web development at all. I teach security. This is the overlap. Okay, so how does web application work? Well, you've got a couple parts. You've got the client side and the server side. On the client side, you've got a web page, typically written in HTML5 nowadays, and runs with JavaScript. And so that runs and is displayed on the client side, and then the JavaScript runs, and it may make requests over to the server. Server runs several programs. Of course, you have the web serving software. There are several versions of that. Apache is very popular, probably because it's free. That really improves its popularity. There's also the Internet Information Server, which is also free, but not nearly as popular. That's Microsoft's version. And along with the web serving software, there's often the ability to run multiple programs or programs of different types. They run in the web server environment. And they have a variety of languages that they've used. PHP is very popular. And you can also write JavaScript. Express.js, Node.js will run JavaScript on your server. So you're running JavaScript on the client and the server, and that makes it pretty easy to go from one to another. I can tell you, having programmed PHP programs on the server and JavaScript on the client, it's pretty easy to go back and forth, except I forever get confused about concatenating strings. One of them uses a period, one of them uses a plus, and that always screws me up. Anyway, so you have JavaScript, you can have Java. Java servlets will run on the server, and you can write a Java program to do the server side. Python is becoming more and more popular. You can have Python programs running on the server, and you can have compiled programs. That is, you can write a program in C or C# or C++, compile those, and then run those in the server. There is a performance improvement, of course, for compiled programs as opposed to all the others I've mentioned, which are interpreted. Some of them have just-in-time compilers, JITs, just-in-time interpreter. Whereas you get a C program and compile it, and it will run pretty fast, which is only important if speed is an issue on your system. A lot of times students and professional programmers get confused about the need for speed. If your program runs in the blink of an eye, there's really no reason to make it run in half the blink of an eye. Okay, so those are what you can run on the server. We're not talking about the server today, though. Today, we're talking about the general operation of a web application. So a web application, generally, you have a browser, your favorite browser, whatever it is, Chrome, Firefox, Mozilla, running on your client, on your desktop or your laptop, and you type in a URL, click on something, and it goes off to the server, and the server sends you down that page, which it may just be a static page, or it might have created it for some reason. And then it starts running in your browser. The JavaScript may start automatically. You can have aspects of JavaScript start when the program is loaded, or you can wait till you do something like enter a field or click a button, and then the JavaScript will respond to that. And it may be possible to send a request to the server and get information. You can send data to the server. The user types in something, it'll send the data to the server. The server can do what it feels appropriate with that information and send back a response that the JavaScript can display on the screen, replacing or modifying part of the web page. So it displays to the user on the screen. That's generally how your applications run. Start them. As you run, you click on things, goes out to the server, gets new information, displays on the page. The page in general stays static. Sometimes you'll go to new pages if it's a significantly different kind of request it has to implement. Okay, now we're going to get that Zoom poll to work. I have some questions about your background. Let's see how this works. So I'm going to start a couple questions here. So please answer the questions. So everybody see this? Okay, yep. Responses are coming in slowly. There are four questions, I think. Yes, 4 questions. Just be honest about what you know. If we were live, I'd just ask everybody to hold up their hand, but this is a technological improvement, perhaps. Okay. We're still a few students short. Oh, one more. 2 of you out there are asleep, which could very well happen. All right. Seeing no further response, and since we've got 90% of you to vote. Oh, there's thank you, the last person. Oh, okay. Somebody instead of voting decided to drop out. Okay, let's take a look at the result. Okay, share the results. Okay, hopefully you can see this. Somebody tell me you can see this.
Yes.
Yeah.
Okay, got it. Thank you. It's in this online world, it's of multiple screens sharing. It's sometimes hard to know, what do you see? Okay, but as you can see, for JavaScript, we've got, most people feel pretty confident being able to, 40% of you, a little over half of you can write a simple one, including, of course, the experienced people can also write a simple program. There's about another 20% who can read it, but a quarter of you do not know JavaScript. All right. After much consideration, I decided I'm not teaching JavaScript in this class, but don't worry. There's places to learn JavaScript, and yes, and we'll go over that later in just a minute. Okay, let's looking down. Domain object model. About 20% of you know the domain object model. 40% of you figure you can look at a DOM program and got it, but about 40% of you don't know what the domain object model is. That's a significant number. That's a little different than I realize it's only 15% different, but that's more than we saw on the, okay, JSON. All right. About 35% of you aren't really good at JSON's really simple. So we're going to let that pass, and I'm going to tell you where to learn about JSON, because some of this stuff you can learn about better than listening to me. All right, HTML. Oh, that's a little bit different. Almost everybody can do something with it. There's one poor soul out there who isn't very good at HTML, and they can contact me later and we can work on that. This is not a web development class. We are not going to be writing web pages. We have to look at web pages and kind of have an idea. So the can understand a simple web page is all we really need for the class. Fortunately, about 70% of you are pretty good at making a web page. So we're good at that. Our issues are JavaScript, DOM and JSON. Okay. In that case, somewhere in the future, most likely an asynchronous lecture. In other words, you'll probably find one of those pre-recorded, watch at your own time sort of lectures on the domain object model. For JavaScript, JSON, and well, nobody really cares. For JavaScript and JSON, I recommend you find a tutorial on the web and take a look. We don't need detailed information on this. Again, this is not web development. It's just web security. My favorite website for this, okay, I better write this down. Okay, let's stop this and yeah, let's, whoa, what happened there? Okay. Just a second, I'm gonna make an update to my slides. If my slides will update, oh yeah, okay. All right. And boy, this is such a user-friendly system, I can hardly stand it. Please stand by, we're almost there. Okay, that was much harder than it needed to be, but hopefully now you are seeing the w3schools.com. That's one of my favorite websites for learning stuff about the web. It's pretty easy to understand. It's, click through it. You can pick up this stuff without having to know a lot of other things. So I recommend it. Although there's all sorts of places you can learn it. So if you are in that group that doesn't know JavaScript or doesn't know this JSON, then go out there and take a look. Now, if you don't know the DOM, you might also go out there and take a look. I'm going to, but I'm also going to try to make a lecture for you on how to do this, because there seem to be some issues with that one. And it's sort of important for the security stuff because it's a basis for how the web browser works. Okay, so you JavaScript people or non-JavaScript people and whatever the other topic was, we will just go out to W3 Schools and take a look, or Google up whatever you like and take a look. But try to get that. We're not going to be writing JavaScript programs much, but you need to get into the I can read JavaScript level. All right, so enough of that. Speaking of JavaScript, well, what is this JavaScript stuff? Okay, it's a language. It's a language frequently used in web applications. If you look at it, almost any web page, you see there's HTML and a tag that goes, bracket script, and following that is usually JavaScript. Used to be you had to say what kind of scripting language, but now JavaScript is taken to be the default. So if you're using JavaScript, you just put script in, it figures it out. It's a scripting language. It is not your instructor's favorite language. It has several of the flaws you'll find in scripting languages. Some people think are just so great, and I think are just so terrible. Since I'm the teacher, I can sit here and complain about things. I'm going to tell you the idea that you do not have to declare variables. People think, oh, how wonderful. You don't have to bother declaring variables. Languages that declare variables don't do it just to annoy you. There's a good, strong reason why that's there. So anyway, okay, so it's out there. It's object-oriented, and it's got a lot of libraries you can use. It's except for some problems, it's a pretty complete language. We created it way back in September 95 with Netscape, and it integrates very well with the domain object model. And for those of you who don't understand the domain object model, just wait a few slides, we'll get there. And again, here is my plug. I thought I had it there someplace for W3 Schools to learn JavaScript if you don't already know it. JavaScript is not the only language you can put in your web page. Originally, before, as the JavaScript was coming out, Microsoft was okay. Microsoft won the browser wars. Browser wars, yes, the browser wars. You can Google it or look in Wikipedia if you want. Oh, back in the dawn of the web, Netscape was one of the earlier browsers. And it was championed by AOL and a couple others, and it was out there as one of the first big browsers. Microsoft came out with Internet Explorer, and they battled to see who could make the better, most popular web browser. And they continued to enhance them. Netscape came out with JavaScript. Microsoft, always, not wanting to get caught short, came up with their own language because they were worried about, if JavaScript belonged to Netscape, they couldn't just use it. It hadn't been standardized yet. And so they came up with something called JScript, which is just about the same as JavaScript. They also had other languages, like there was a Visual Basic scripting language, VBScript. Microsoft has promoted BASIC since the dawn. In fact, your original IBM PCs, which ran Microsoft DOS, if for some reason it couldn't boot, because back in those days, they had like floppy disks and no hard drive. If you didn't put the DOS floppy disk in there and you press the start button, if it couldn't boot up, it went to a built-in BASIC interpreter, and it would just run BASIC. And that was Microsoft's BASIC. Anyway, Microsoft's promoted BASIC for a long time. It's still out there. BASIC's a pretty miserable language, but Microsoft likes it. So they had Visual Basic. Unfortunately for Microsoft, fortunate for the rest of us, JavaScript became much more popular. Even though Microsoft eventually became the dominant browser, and an Explorer became dominant, and Netscape faded away along with AOL. I think AOL is actually still alive, but who would notice? But Microsoft didn't do a lot with client-side programming, but that came to be standardized. Okay, I want to talk about a couple of the file formats that we're going to see when we talk about browsers, and they're important in how we communicate and how web applications work. And so I'm going to talk about these. And again, you can always Google them up if you don't understand what I said. Look in W3 Schools or find something else. Okay, a very popular means of storing information and transmitting information is XML, Extendable Markup Language. For that 95% of you who know HTML, it sort of kind of looks like HTML. Both of them are created from the generic markup language, or GML, which nobody knows, but HTML is there to define a document format to some extent, how a document should be displayed, what should be displayed on the screen, whereas XML is a data format. It is used to hold data, not to define how it is displayed. XML is a tree-like structure, and it's in text with lots of silly brackets, lots and lots of silly brackets. So it defines a tree of information. Now, there are some differences between XML and HTML. HTML can be pretty sloppy. Browsers are very forgiving of miserable HTML. If you forget the closing brackets and something, it'll figure it out. You almost never get an error message saying, I can't show this HTML page. It figures it out how to do it. XML, on the other hand, is picky. XML requires it to be in correct format. You miss a bracket one place and it just says, oh, poorly formatted, and that's all you get. No, your XML file has to be correct. It's case sensitive. We have tags, and the tags are case sensitive, whereas in HTML, they're not. You can write H1 or lowercase h1 any way you like it, and it will still work. Now, in HTML, you have a bunch of tags you might, IMG or P for paragraph or something, but there's a defined list of tags. In XML, there's not a defined list of tags. You can make them up as you see fit. So you can have all sorts of tags. I have an example XML program. Okay, so in this example, the first line is the XML prologue. It is optional. You see it in most XML files that you look at. It's out there. If you have it, it has to be on the first line. And it tells what version of XML you're using. And then it also says what file encoding. UTF-8 is your standard ASCII-like encoding. That is a 8-bit character set. If you have UTF-16, it's like Unicode, but this is 8-bit. Usually things are 8-bit. Okay, after that, you have a bunch of tags where you start with the bracket, name, end bracket, and that goes. So you can see we have a book, it starts with the bookstore. Bookstore is the root entry. There has to be one root tag here. In this case, it's bookstore. And then underneath bookstore, you have book. There are two book objects. One starts on the third line, and it goes down for about 4 or 5 lines to /book. And then there's another book. And inside the book, there are 3 other entities. There's title, author, and price in this example. Again, you can make up the tags as you see fit. So the tags, again, start with the greater than sign and end with a less than sign. Or is it less than, greater than? Well, anyway, the opening bracket and the less than bracket. So you got the name there. And then in between the tag and the closing tag, which ends with the same tag name, but a divide type slash in the end, you have the data. So in this example, we have data inside between the start tag and the end tag. And so we have data for all the sub-ones here. I could have put data inside the book entry, but I did not. In addition to the tags and the data, there are attributes. Attributes are information you can add to a tag, just like you would in HTML. In this case, the book tag has the category attribute. And you can see here, the first book is the category children's, the next book has the category web. And so the attributes are optional. And I might suggest that when using XML, particularly if you're defining XML files, minimize the use of attributes. Some people put too much stuff in their attributes, where they might better put it as a tag value or tag data. Note, by the way, that attributes are always inside quotes. So even at the very beginning where it says XML version equals, version is an attribute, quote 1.0, quote, that is, it's inside quotes. There's also the namespace, the Java, the XML namespace, here XML-NS defines a namespace, and that defines resources for the tag. In this case, it isn't really important that the website contain any information at all about the XML file. In this case, I've got the university website. That works perfectly well. The university website doesn't have any information about XML. It doesn't matter. You have to have something there, and it's okay. Just give it a website. It's not going to go out there and look for a file or something. All right, so that's XML. And again, if you have confusions about XML, not even sure you can spell it, you can go out to W3 Schools and learn all about it. Become an expert, much more than I am. Okay. Now, although XML allows you to make any tag you want to, that can be a problem sometimes when you're trying to get files that are going to be used by a particular application. So you might be concerned that you want this XML file to have only certain tags, and then only certain types of data in those tags, and other defining information, which is okay. You can require that your XML file conform to a certain specification. You can require it to be validated. And validation just is a test to make sure that the XML file meets the requirements of the validity schema. It checks what tags, what kind of attributes you can have, what kind of data is in the file. And it restricts the XML to a particular set of tags and particular type of data. So when your application is using it, you can be pretty well assured that you only see this type of tags that you expect to see, and you won't see anything that the user wants to put in there. Also, remember that XML is case sensitive. And my favorite error is to improperly case a tag where I decided originally it was going to start with the uppercase letter, and later I type it with a lowercase letter, and it isn't going to match. But not to worry, if you have XML validation, you can run a check on the file, and it will tell you, hey, this tag is not correct. There are several different ways to specify how the XML should be validated. The most popular one is a document type definition, or a DTD. And this involves all sorts of details about what attributes you can have and what tags and the other stuff. There's also XML schemas that you can specify. And there's about half a dozen schema languages you can find on the web to specify how a tag, or excuse me, how the XML file should be validated to ensure it only has certain types of tags in it. XML is pretty widely used. Its use over the web is starting to diminish, but it is widely used in other applications. The Simple Object Access Protocol, which used to be a very popular protocol for distributed web applications, not as much now, but it used XML. Other files use XML. Vector graphics. If you get an SVG file, if you open up an SVG file in Notepad or something, it's an XML file. It's just XML specifying how the graphics should be displayed. Yes. And now, not everybody loves XML. There are some issues. It's criticized for verbosity. Yes, if you look at XML files, you look at the example we have here, there's lots of brackets and lots of beginning tags, closing tags. Yes, it does compress pretty well because it's got so much redundancy in it. Compression works when there's lots of redundancy. It throws out the redundancy and squeezes it up real well. But by default, it's not compressed. So that's not. Anyway, it's got its advantages. I have used it in applications I've written on my computer because it does make it relatively easy to specify multiple objects of a specified type and then go looking for objects of that type. In Java, there are, if you write programs in Java, as I do, there are several means of opening and accessing a XML file. You don't have to go through and read all those little brackets. You can open it up in different things and say, give me an array of all the items of this header or this tag. Okay. Now, XML is used for distributed applications at times. Particularly, there's a system called AJAX, which is the asynchronous JavaScript in XML. And it is a method where a JavaScript program can request an XML file from a server, and then the server sends it the XML file, which the JavaScript then decodes, gets the information from the XML file, and displays it. And again, the JavaScript program doesn't have to deal with all the little brackets. There are tools and objects and methods that will take apart the XML for you, validate it, and give you the particular information that you need. XML is not used as much as it was because of the difficulties that were talked about earlier, kind of redundant, heavy duty. What's more popular now is JSON. JSON is the JavaScript object notation, and it's used very commonly for sending information between a client and a server. One of the big advantages of JSON is that it can be easily converted to and from a JavaScript object. In particular, an array. If you look at the example here, we have the variable my data, and it has, it's okay, the whole thing starts at this little single quote, ends at the other single quote, and inside it's a bracket. So it's one big, it's an array of 3 entities that are name value pairs. We have, in this case, the first name is name, N-A-M-E, and the data is John. The next one is age, and the data is 31, and then city, and the data is New York. You note that the tags are always in quotes, and the data is in quotes if it's character data. The number over here doesn't have to be in quotes. The 31 isn't in quotes because it's a numerical value. So numerical values don't have to be inside quotes. And of course, being JavaScript, you can make this more complicated. Instead of having strings or numbers, you can have other objects and embed arrays inside arrays and make it a mess. But that's all supported. And so here, my data is a string that contains a JSON-like string. And then you can parse that with the JSON package, json.parse, and it creates an object that is a JSON object, and you can ship that JSON object off to your server. Anyway, and you can then, on the other direction, you can get an object from the server and easily parse it into a string, or excuse me, not a string, but a JavaScript object that is an array, and just use it as you had a JavaScript object. So it works very well with JavaScript. Oh, that little circle on the upper right is the JSON logo. Okay, domain object model, which most of you claim you don't know. So I'll give a brief 2-minute overview right now, and we'll come back to it later in another lecture. But the domain object model, or DOM. DOM defines the objects in a web page, in HTML. Each piece of text, each button, every piece, all the pieces of your HTML, and of course they are hierarchical, are part of the domain object model. You have, the whole HTML. It breaks down to divisions and paragraphs and other pieces, each one of which are objects. You have all these objects, and they're all part of the domain object model. And so all the pieces of your web page can be described in the domain object model, and therefore you can access it very nicely from JavaScript. JavaScript programs can go out there and do things with these objects. They can change them, add, remove them, and all that. So all these objects in your web page can be accessed from a JavaScript program. Let's see. Okay, here's an example. All right, this is a really simple example. In the beginning, first HTML line there, the bracket P, which starts the paragraph, and you can see the end of that line is a /P, ends the paragraph. And the paragraph says whatever. And it has an ID. The ID is demo. In other words, it's pointing to, I have given a name to that paragraph. Demos, of course, not very informative, but it explains for the demo what we're doing. So you've got an ID demo, and it's going to display. You don't see the word demo on the screen. You see the word whatever. And if this is all there is for the page, then you're just going to see whatever in the page. Okay, and then there's some JavaScript. Starts with the bracket script on bracket, and ends with the /script. And inside there is a bunch of JavaScript. In this case, there's one line. It's a one-liner. And document, the name document is the root of the domain object model. That is the, it's a JavaScript object, and it has a variety of methods and properties that you can call upon. The method I'm using here, the get element by ID. Yes, that's, sometimes it says get element by ID. It says, I want to get the element who has the ID demo. Well, fortunately, I have an element there with the ID demo, And so it's going to return that object, which in this case is a paragraph. So the first line of this is from this document, this web page, get the object that has the name demo, the ID demo. That's a paragraph. And then .inner HTML is a property. It says, what is the HTML in that paragraph? And I'm going to change it. I'm going to set the data or inside that paragraph to hello world, because everybody sets it to hello world for your first programming. I mean, ever since Kerrigan and Ritchie, we've been writing hello world all over the place. So it sets to hello world, and that will replace whatever. And so now the web page where it used to say whatever will say hello world. Pretty dull example, but it is an example of changing your web page through modifying the domain object model. Okay. Oh, another aspect of JavaScript that's very important for the web security and for asynchronous updates is the JavaScript object XML HTTP request. And it is an object frequently used to communicate in JavaScript with your server. Now, the name is XML HTTP request, but in fact, you can send any kind of data you want to. And most of the time, it's sending JSON formatted data. But whoever created the object thought that was back when they thought it was all going to be XML, so they called it XML. But now it's just sends a bunch of bytes. Bytes are bytes. It's going to send a bunch of bytes from your program to the server, and then possibly get a response from the server back to your program. And the object that does this background communication is the XML HTTP request object. Oh, okay. Now, there are several methods and properties of the XML HTTP request object. Now, you can create an object. I've got an example coming up. A couple of the interesting ones is on ready state change. That's an event handler. And typically, you set that equal to a method. You can either, frequently people define a method in line, or you can have a method in your JavaScript program and say, I want this method call when the state of the XML request changes. So states are things like I sent the request, I've got the request, and errors occurred. These are states. We can get the state from the ready state property. So if you create an XML object called dog, you can go dog.readyState. It will tell you what the state is. 4 is an interesting number. It's a numerical value. 4 says the request is done. That is, when the ready state is 4, it means, everything is finished. If you're sending something, getting it back, 4 says we're all done. We've got whatever you asked for. And then there's the status property. Status property is the HTTP status. We talked about that last week, but 200 is the happy message where you've gotten everything back. 404 is file not found. The others, 500 something says the server doesn't like you or it's not going to respond. And the last property of the XML request I wanted to mention is response text, which, as you might guess, that's the text that's returned. So if you make a request off to a server, you send it a request, a GET request to a server to get files. The GET request also may have some parameters. Sometimes you want to get some information with particular parameters, or not. Sometimes you just, give me the request. It's always going to give me what I want. And then when it comes back, the response text is the text of what you want. Okay, so here comes an example. Now, I wrote the example. I'm not showing you the example I wrote because it's the best example you'll ever find of a web application. Probably not. But I understand it very well because I wrote it. And I don't have to worry about any copyright issues or patents. This is mine. Okay, so it comes from my firewall simulator. I don't know if any of you have had the joy or horrors of participating in my firewall simulator system, but I use it for a web security, or not web security, network security class. And every student has a virtual firewall, and they're the network manager, and they have to configure their firewall. And then after they get it configured, and the instructor starts things up, they can send predefined attacks against other students. You can pick a student, pick the type of attack, and say, go do this against another student. And then that will happen, and the server looks at the attack type, looks at how that student configured their firewall, and if they configured it correctly, it sends you back a message saying, didn't work. Or if they didn't configure it correctly, then you gain a point and they lose a point. And it's fun. People get a lot of, people struggle to get lots of points. It sends information to and from. There's some information, such as the list of players, which includes everybody's scores and other such information, that's displayed on a regular basis. Every few seconds, it goes out and asks the server to give it an updated list of the players. And so that's what we see here. This is the get list function, and a JavaScript feature says periodically do something. Periodically, it calls this list every so many milliseconds that I define. Okay, so this function gets called. Let's take a look at this. The first thing it does is creates an XML HTTP request object. This is your standard, even if you know Java or only C++, you can see new. Yes, new. We're creating a new object. And so XHTTP is the XML HTTP request object. All right, so we're requesting the object. And then we say on ready state change equals function, no parameters, curly brackets. And then so all the stuff here is the function that we are going to call. We notice we're defining the function in this one statement that will be called whenever the state changes. Whenever the state changes from one state to another and the status. So typically in almost all these functions, the first thing you do is you check the ready state. Remember, ready state tells you how far it's progressed. In this case, we're looking, is it 4? Remember, 4 is the value you get when it's all done. So we're going, okay, is the state done? Are we done? If we're done, then you check the status. Is the status correct? In other words, did it return 200? By the way, you need to check and say, well, what if it is done, but the status isn't 200? What if it broke? That's always a possibility. Don't write programs that ignore errors. So do as I say, not as I do. All right, so if, in fact, this is great stuff. In other words, if we're done, if the request that we sent is returned and we got the data back, then here xhtp.response text is the response text. That's the text of the information that was sent back from the server, the list of players. And it's a big JSON object that contains, it's an array of player information, their names, their scores. So this is passed to the JSON.parse method. And so now play array is updated. It is a array of information returned from the server. And then this player update, that's a function I didn't show here. And then it takes the player array information and displays it in a pretty format on the screen. Okay, so when state changes, when we make a request and the state changes, then it's going to call this function, check and see if we're done and everything worked okay. Take that text, parse it in JSON object, and then call a method that will nicely display the information. Okay, so now our way down here says xhtp.open. Open tells you what are you going to do. We haven't quite started. Open has a couple parameters. The first one says, well, what HTTP verb or method are we going to use? In this case, get. I'm going to call the refresh players.php requirements. That's a file on my server. It's a program written, obviously, in PHP on the server of this application. And it's going to go out and call that, send this information to the server saying, run the refresh players.php. There are no parameters. It gets the same information every time. Well, unless the number of players changes, the scores change, but yeah, it doesn't matter. You always get the list of players. And so it goes out in there and runs that program on the server. That program generates a JSON file, which is then returned back to this program. And of course, we get it above and display it. And there's a third parameter here, which is set to true. And I don't remember what that true means, but you can look it up if you need to know. Okay, and then finally, the last line of this example, http.send calls the send method on our object, and that says do it. That means send the request to the server. Open tells you what you're going to do, and then we're all set. So there's several things you need to set up before you do send. In other words, you have to basically send is almost always the last method you call this object. You create it, you tell it what to do when you're done, tell it what you want to do to get going, and then you say send, which does it all and sends the information over to the server. And in this case, gets the information back. Again, this is doing a get. You can do puts or patches or posts or whatever your favorite HTTP verb is. Okay. Now, XML HTTP request is not the only way you can do this. There's also the fetch function in JavaScript. Fetch is actually, once you figure out how to do the fetch, it's a little bit more flexible. It's a function that you pass a URL. That is, it could be something like refresh players.php. That would work just fine as a URL. And then you, what are we, oh, God. Sorry, we get, okay. Something zoomed me to the bottom. All right. Anyway, you can see the fetch call here. Now, fetch is an asynchronous method in JavaScript. JavaScript has the concept of asynchronous methods, and this is inside an asynchronous function. It returns a promise. Promise is an object that says, when it's done, I'm going to have the information that you wanted. So await says, kind of undo the asynchronous. We're going to do a fetch, and then we're going to wait for that fetch to happen, and it's going to return a promise. So my object, in fact, is a promise. And we wait for that promise to be fulfilled, and then once that promise is fulfilled, we will get the text from that object. And now my text will be it's a string that contains the data that was returned. And next thing we do, we call this my display method, which I don't show, that will display the text. Okay, so that's using fetch instead of XML HTTP request. There are a couple ways to do this. All right, any questions about these two functions? They're kind of a basics for sending information over the web on a asynchronous background issue, and that's what most of your web applications are doing. And of course, by the way, if you ever have a question, issue, shout it out. I am not actively looking at the chat, by the way, because for reasons I don't really understand, doesn't always show on my screen. Okay, so but moving right along then, if everybody's happy with XML update and fetch, knowing, of course, that if you don't understand what the heck I'm talking about, you can always go out to W3 Schools and look it up, or anyplace else. Yeah, there's a couple, in fact, I looked it up in several places, and there's a couple of nice websites out there. Okay, now when you go to get something, particularly XML HTTP request update, you need to go to the same server from which the web page originally came. In other words, you have the origin web server. That's if you type in the beginning URL and you go www.acme.com / mypage.html, then XML HTTP request makes request to the www.acme.com website and not other websites. This is the same origin policy. It's not allowed to go to other ones. You have to go back to the service where you came. Now, there are exceptions to the rule. You can, when you define the HTML, you can specify other things that are, images, videos, cascading style sheets, all of which can come from wherever you want, other servers, other places. Yeah, I make web pages instead of copying pictures from someplace. I just use an image link in my files as we'll go over to where I found it. Okay, so this only really, same origin policy only applies to scripts, to JavaScript. If you are doing a JavaScript, basically what I'm saying is an XML HTTP request or a fetch, then it's got to go back to the same host where you requested. Now, why is this a problem? Well, let's think about this for a minute. Let's imagine you're out there accessing your online banking. And so you're going out there and moving millions of dollars around from your accounts. And then you're done with that and you want to go out to some other website. And so you just go someplace and click on it. Well, okay, you may have forgot to log off. Maybe you're on another window and you didn't log off. You're still doing it. If that second, we'll call it the malicious website, says, oh, let's see if they're banking with Bank of America today. And so they'll go out and access the Bank of America site. Because you are possibly logged on or you didn't log off, you are authenticated to the Bank of America website. And so requests that come from your system will be assumed authenticated, because as it sends these requests, the browser passes the cookies along, and there's cookies that authenticate you. It's because when you first logged on, the system sent your browser or your browser a cookie, which it then sends back. And so now, if you're sending a JavaScript request from another website, it's going to the banking application. It's going to send that banking cookie, and the bank's going to think you're authenticated, even though the malicious website is not doing probably what you want it to do. And once it has access to your bank account, it can do whatever it likes, move money to other accounts, check all sorts of stuff. So that's the problem with having JavaScripts that use XML HTTP requests that go to other websites. Now that can cause some difficulties, and there's some loosening of the restrictions you can allow. There's the cross-origin resource sharing, or CORS, or CORS. It's a mechanism that allows you to get certain restricted amount of access from a JavaScript program to another website. Under certain conditions, you can go out to the other website. Basically, you can go to the alternate website if the alternate website allows you to do this sort of stuff. Now, some websites don't care. Everything on that website is considered public. There's no private information, so it doesn't care if you go out there. What the heck difference does it make? There's nothing that anybody can't see. In other words, the bank would not allow it, but maybe Wikipedia or somebody would. So you can go there only if the other site allows. Now, I've been experimenting with this. I've written a bunch of experimental programs to try to go out to other websites. And there's a HTTP option called mode, and you can set the no-CORS mode, and that's supposed to say, well, don't bother with this CORS stuff. We'll just not do it. We'll just go. And I wrote a program using fetch, and if I specified no CORS, I could go out to a third-party website. And if I didn't, it would give me an error when I tried to do this. Alas, in the world of non-reproducible results, I haven't been able to do it again. I mean, it worked once, and now it won't work. And I tried to extend it to another application, and then it wouldn't work. And then I went back to the original one, and it still wouldn't work. So I don't know what the heck is going on. So I wouldn't count on that little feature working. But it worked once for me. Maybe the weather, the moon was right. Okay, here's basically how CORS works. I don't know if you can read this, but I stole this nice diagram from Wikipedia. Okay, say you're going to make it up, starting in the upper left-hand corner, you're going to make a XML HTTP request. And first thing it is, well, are we using a get or head verb? The get just gets information from that website. Yes. If that's a yes, then it says, well, do you have any additional headers? I mean, did you add headers to the request that wouldn't normally be there? And again, when you do an XML, one of the things I didn't show is you can add headers. You say, oh, you better add this header. You might add a header for authentication or something else that needs to be there that isn't normally set, but you want set when you go to this website. You can put that on. Okay. If you did a get or a head, oh, by the way, get obviously gets a file. A head just gets the header information. We'll talk about that in a minute. And if that's the case, and there are no other ones, then fine. Hey, go off and just make the actual request. We don't care. But if it's not a get, this is, well, is it a post? And then as a post, was it just a standard sort of post? And is there any custom, if standard type of post and there's no headers, well, better we'll make that again. But if in any case you're doing something possibly in any way weird, then it's going to send a request to that server. In other words, if you're, say your program is on www.ncat.edu and your web page wants to get some information from www.acme.com, and you're not doing a normal head, you might be wanting to do a put, because you're going to update some information on the website. Well, okay. Then it goes out here and it sends a HTTP request off to the www.acme.com server saying, do you allow cross-system requests? It sends it with the options. Options is one of the HTTP verbs. There's get, put, patch, post, and options. Options is tell me what options you allow. But that's the purpose. Tell me what you allow. And you send a request with the options saying, what is the origin of this request? And then it responds back. And the response in the headers include access control header with the responsive star. In other words, the access control options header say, oh, I allow access from anybody. You can say I allow access only from this particular web page, but you can say, do you allow it from anybody? If it's not there, in other words, if this program doesn't say, oh, yes, I'm going to allow access from anybody, you got an error, prints a nasty message in the console of your browser and blows your program off, or your script of your web page stops executing. On the other hand, if everything's happy, it then goes and makes the real request. So we start with a local request. Now, you know, by the way, that this request is served locally. In other words, the decision whether it's going to allow or not allow a request is made in your browser, not by the server on the other side. The server makes a request because you asked it, and then the local browser decides whether that's good or not. Okay, so it's a local decision based on what information it might have asked of it. So if your local system decides not to behave well, you can do whatever you want to. And of course, that's the security issue that we will talk about later in this course. Okay, now, why would you want to go to other websites? Because there's a concept of APIs, application programmable interfaces, where you have all sorts of web services out there that you can connect to. There's a style of web, a pattern of web, I don't know what you call it. There's REST APIs, representational state transfer, which is abbreviated REST, and very few people know that REST stands for representational state transfer. But a REST API provides an assortment of applications that you can call, or excuse me, your application can call these services on the other ones. And basically, they're just web pages, or not necessarily web. You can access them with XHTML and go out there and get them. And it returns, usually send data, return data in the JSON format. Now, particularly useful, most applications do the CRUD stuff, C-R-U-D, create, read, update, and delete. That's the standard sort of thing you do to a web system or a service. Create, you want to create some information. And of course, HTTP post, so you send some data with a post command, and that sends it off to the web application. You say, create an object of this type. And of course, if you want to read data, you use a get, very much like you might get a web page. Doesn't have to be a web, just a JSON page. Of course, you can update it. Maybe I want to add some information to the page or change something. Put or patch are two HTTP verbs that you can use. And to delete item, well, of course, the delete HTTP verb is what you'd use. Now, that's your standard web service API. To be a REST type API, it has to meet these 5 constraints. Well, client-server architecture. Well, that's pretty much what we talked about. The client sends it some information, and then the server sends information back. It's a web-based client-server system. It has to be stateless. That means that the server is stateless. The server doesn't keep any information about what you did. And so every time you submit a request with the same input information, you get the same output information, which makes it very easy to cache. It's cacheable. Cacheability? I don't know who made up that word, but yes, so you can cache it because if you send the same input, you get the same output. If some system along the way has cached that response, then it can send it back. You doesn't have to run the application again. You just know what the answer will be. Now, statelessness has some implications. If you need to be authenticated to access this information, the typical thing is you enter some credentials, maybe simple enter user ID and password, send that along. It says, okay, I believe that you are you, and then you ask for information. Well, server's not saving any information. So if you send information to the server to authenticate, it then sends back information. It'll probably send back a cookie that contains authentication information. And then that cookie or authentication information has to be sent back to the server to request information. And so not only do you send the parameters of your request, but you'd also send the authentication cookie so that the system would know who you are and whether you're authenticated to do this. A layered system kind of responds to caching. That is, if there are some other systems between you, your program, your application, and the server that maybe cached it, that served other functions, they're invisible, that you can run these because it's all cacheable. And then uniform interface means that everything functions in a standardized way. It uses HTTP and usual type response. Now, I don't understand how all this works. You think, yeah, I'm teaching this class. You expect that the instructor would know what the blazes he's talking about. I'd like to think that I do, but that is not always the case. And I confess, I don't quite understand it because I've been reading about this, writing test programs left and right. And yes, everybody wants these cool, web applications that go out and goes to this website to get information and that website to get information, and then display it on your website. Well, the same origin protocol, the same, and the course requires that you can only go to your website. Well, how do you go to these other websites? So I'm trusting that you students who know what you're talking about, and I notice that some of you say, oh, yes, I have written other websites and I'm an expert at JavaScript. Well, here's your chance to shine at being an expert. Send me an email, please, and tell me, how do I do this? Because I'm not sure basis. How do I do that? You've got one side of the system that says, that's what you want to do. And the other side says, wow, but you can't do that. So let's figure out how to do that. And then we'll figure out how to hack into it. Okay. Any questions so far? If you had a question, you should have screamed it out. All right. So moving along, following our textbook, if you've been reading the textbook, and it's not a bad textbook, it's pretty easy to read. That's up to date. The textbook says the next thing we should talk about is reconnaissance. If we're going to go out and attack somebody, we need to know who they are, what they have, and what they're running, and stuff like that. There's an awful lot of information you can find out and we'll talk about that shortly. But basically, one of the things you want to know is, well, who we're going to get. Is there just one website we're interested in? Typically, there's more than one server involved in even a moderate-sized system. And of course, the huge systems like Amazon or Google have huge server farms in some bunker throughout them. Actually, I think, doesn't Amazon or Google have one here in North Carolina? Anyway, they have huge server farms with using vast amounts of electricity running this. That's not what I'm talking about, although that sort of applies. What we're talking about, you have a relatively simple system, and you might have one server that runs your catalog. So you're browsing through the catalog, you want to buy something, and you're looking at the catalog, clicking from one item to another, searching for, where do you find a widget? One computer might be answering all those questions. And then when you want to order something, you say, oh yes, put this in my cart. It jumps over to the ordering system, which handles orders. And then when you say, I want to pay for it, it jumps over to the billing system, which handles all the finances. And who knows how many other servers there may be out there. There's probably a server they use internally for shipping. So they can, the guys in the warehouse get the information about put this size widget in a box, put this label on it, and give it to UPS, and away it goes. So you have a bunch of, now you expect the catalog server to be pretty much, might be very well hardened and protected because they expect everybody to use it. They may or may not have put the same amount of protection on some of the other servers because they don't expect you to access those. They don't expect you to know they're there. But they're there, and they might be the victims you want to attack. So part of reconnaissance is going out looking for them. How do you find them? The Chrome debugger is one way to do it. We'll look at that in just a minute. Another easy way is to look in the HTML page, read the HTML. You get the web page, you can look at it in the browser. You can just save the HTML page and go through it with your favorite editor and see what they're doing. You look for all of the links they go to and find out where are they going to get things. There are other tools for doing this. Snort is a popular tool. They advertise itself as a protection tool, although I've never seen anybody try to protect themselves with it. See everybody try to attack with it. Snort has a feature where you can go out and say, well, go to this website, go to this range of addresses and tell me all about the computers that are on that. And it will do that. It's pretty good at that. But that's covered in the web security class here at A&T. So if you're interested in that, take Dr. Shu's web security class and learn all about Snort. I'm not going to talk about Snort here. Now you've heard all you're going to hear about Snort from me, but it's out there and it's pretty effective. Google also allows you to search for things. So you can sometimes you can just search for the information you want. Isn't Google wonderful? You can go out and look for it. Sometimes you have to be a little more careful in looking at your search because sometimes a simple search will give you more information than you could possibly stand, but with a little care in formatting your search. And you go into the advanced search and you specify what sites you want and stuff like that. You can do that. And then one of the other ones I wanted to mention is phishing. Phishing is sort of outside of the scope of this class, but phishing works really well for attacking any system. Phishing is asking a human being for information. Typically, you send an email saying something. So you might send an email out to somebody and say, oh, what's the name of that server you use for billing? And if you ask the right idiot, he might send you back an email and tell you. Humans are the hardest part of the system, the weakest link in any computer security system, because who knows what they'll do. Okay, now I want to take a break here. And I said that that you can find information in the debugger. In this case, I'm using Chrome. So we're going to go look at, where did I put that? Oh, okay. Let's look at this website. Okay, hopefully you can see this. This is, I went out to Wikipedia, I looked up reconnaissance because that's the topic of the day. And then after I clicked around in order to get enough web pages to do interesting things. I then went to the debugger. You can go again on the little dots, go down to developer tools. Oh, gee, I clicked them. Watch how you click it. And or Control-Shift-I gets you to the debugger. So I got to the debugger, clicked on the network tab, shown there in the middle, underlined network tab, and it shows you all the connections it's made and the responses it got. So I go over here, and if I mouse over, let's say, reconnaissance page, it tells me it came from en.wikipedia.org, blah, blah, blah. EN, of course, stands for English, because Wikipedia goes in like zillions of different languages. And so that came up. And then I go, well, okay, that's the website I know. That's the website I accessed up here. Then I go down to the next one. I go, oh, hey, look at this one. This one's upload.wikipedia.org. That's a different website. And then there, keep going. This one's also upload. Upload's really, I get more from upload than from EN. Others. So you can see in the debugger of Chrome, and of course, there are other debuggers for Firefox and Safari, whatever is your favorite browser. You can see how it works. So there you can look and see, where do these come from? You go, oh, those are some of the servers that this system uses. Okay, so let's go back to our web or PowerPoint, so I can PowerPoint poison you. Oops. Okay, there we are. Everybody see the finding servers page?
Yes.
Say something.
Yep.
Okay, good. Again, boy, it's all secret. What does everybody see? I know what I see, but I can tell you from experience, sometimes you don't see what I see. All right. Now, how do we keep people from accessing our other servers? There are several ways to do that. And I stole these slides from Dr. Yu. Dr. Yu, Dr. Yu has always taught this class. And I went out and looked at her slides this morning and said, oh, look, she has a couple of slides of what I wanted to talk about. Since I had spent hours and hours working on slides, I was getting desperate. I stole some from her and then completely reformatted them and changed them. But anyway, here they are. Okay, so you may have, as I mentioned, one web server that you make publicly available. Everybody goes like to en.wikipedia.org or to www.mybank.com, and that's what you expect. But there are other servers maybe out there. But how do you keep people from using the other servers? Well, a very common and very ineffective means is just, no, I won't tell anybody they're there, and therefore they'll be secret. So just don't mention it to anyone. Yes, so they're out there, but you don't tell anybody, and you hope that nobody will find them. As you might guess, that's not a really effective method. So it is, on the other hand, the easiest method. And if you don't really care that people see the other servers, let's think about Wikipedia here. The other server's got files that it's uploading. All that information is available. I mean, there's nothing on the upload server that you can't access through some web page on the enwikipedia.org site. So who cares? So they just don't tell you about it and hope you don't find out. But if you do, it doesn't matter. If you find out, it doesn't really hurt. So, and of course, sometimes you don't want people. Oh, I think I'm getting ahead of myself. That's what I was saying here. Okay, don't tell people what they are. Hiding the URL. Just don't tell them. If nobody finds out. And again, it's the easiest thing to do. If anybody who knows it, of course, if anybody finds out it's there, they have full access to the website. So it's not very secure. But if you don't care, it works just fine. Okay, so that's one technique. It turns out to be a relatively popular technique, which is what makes web hacking so much fun. Okay, another way to restrict it is to say, well, we're only going to allow access from particular internet addresses or particular domains. For instance, at the university, we have the banner system, and the faculty and departments can, well, usually departments, some faculty who demand access, like old computer science professors, can have access to the banner system, but you can only use it from on campus. You cannot use it if you're off campus. In other words, if I sit here at home and I try to go to the website and go into Banner, it won't let me. It says, nope, you're not on the proper IP address. Unless, of course, I tunnel into the campus and then it works fine. But okay, so that's one way of getting around it. It's relatively simple, and it works well for organizations that want to say, okay, this web application or this web server can only be accessed by the people in my network, my intranet, and it can't be accessed by people on other networks. And it's relatively simple to implement. The disadvantage, of course, is that there are other ways to get around it. You can attack the domain name servers, but domain name servers are getting harder to attack. In the early days of web, nobody thought to put any security anywhere, and particularly didn't put any security in the domain name servers, and they became targets. Now they've become much harder because people said, oh, there's vulnerability, and web experts said, let's fix this problem. So they're much harder to attack than they used to be. But host-based addressing is not foolproof, and you can tunnel into it. So accessing it, reducing access to only people in a certain web domain may slow it down, but it's not perfect. A better technique is to require people to identify themselves. In other words, offer some sort of credentials, either humanly, well, human credentials of entering user ID and password, or even more so, like the three-way authentication, where typical thing is I'm going to send a text message to your phone, and then you enter the code that I sent your phone, and that lets you log in. By the way, the Banner system has that security system in it also. And that way works much better than the other two techniques of just don't tell anybody about it, or trying to restrict access to an internal website. You can, of course, use any mixture of these three. You can have a website you don't tell anybody about, and you let only people from the inside, and you require authentication. That, of course, using multiple layers of security keeps it much more secure. All right. Okay, to keep you from getting bored, and I know everybody out there is getting bored with nothing to do in this days of pandemic. I'd like you to go out to WebGoat, and since almost everybody says we've got WebGoat running, go out to WebGoat and do the A3 sensitive data. You'll find on the left-hand side of the, there's a table of contents on the left-hand side of WebGoat, and A3, which is the third one down, sensitive data exposure. Click on that. There's only one sub item, and you do that, and that. And once you get that, upload the answer to Blackboard. Don't tell anybody else, and that'll do it. Questions about that? Oh, you need to have Zap running. You got to have Zap for this one. You need to have Zap, and you probably want to I can tell you, having done it myself, you really want to put the filters for Zap or for WebGoat onto Zap when you're running it. Otherwise, you get all sorts of internal WebGoat messages going back and forth, and you only want to see what you want to see. So set it for posts, or set it for puts, post, whatever it is, and go look for what you have, and you'll see what you need. This is not a hard assignment if you've got this Zap thing down. It's basically, this is an assignment to see that you've got WebGoat and Zap running. Easy enough. Okay, so that is it for today. Just about up to our hour and a half.
You will see. The assignment again? Sorry,
excuse me?
Where's the assignment again? I just logged into Blackboard and I don't see it. Right?
Oh, well, no, it's not there because, hey, I wrote this sucker about, I think it was 1:50 this afternoon.
Okay, yeah.
Okay, I didn't have time.
That's fine.
It's on my to-do list. Do you have the answer already?
I do not know.
If you don't have the answer, then don't worry. I'm going to try to put it up there on Blackboard before you have the answer.
Okay.
So I'm going to do that promptly. And then after I do that, I'm going to start writing some slides on the domain object model and put those out there for you to read. And again, if your JavaScript domain object model or any other aspect of this course is not up to where you think it might need to be, go out and, spend some time browsing through W3 schools. Don't kill yourself at it, but just relaxing, take a look at it. It's not hard to do. It has examples all over the place. They have all these. You click this button and it opens up a page that shows you the HTML on one side and the output on another, and you can update it and run it. I find it really easy to use and easy to learn about things. Also, you can search for an aspect. You wonder, how does XML HTTP request work? Well, search for it and take a look. It's out there. So do that. And of course, if you understand all of it, then don't do it. Okay.
When's the assignment due exactly?
Oh, it doesn't say that. Does next Tuesday at noon. Okay. Oh, yes. Which reminds me, how did people do with the other assignment? That's
I'm not speaking for others.
Here, in fact,
miraculously get above 100.
I have another poll out there for you.
Okay.
So I know some of you have run away. I think I may have bored them to death. But please take this poll. Let's find out how we're doing. It's simple. 3 questions. Okay, everybody else, wake up, click a button or two. All right, anybody else? Okay, click. Couple of you have slow clicker fingers this afternoon. I think I probably bored you all to tears. They've fallen asleep. You can't even wake up to press a click. Okay, but that's close enough. We got about 80-some% of the people to click. Let's take a look and see what the results were. Okay, now you should be able to see the click. All right, how about WebGoat? Well, fortunately, 83% of you say you got WebGoat out there. One of you says WebGoat gets an error. I have heard from other students that if it starts up and dies with a bind error, that usually one of the ways to fix that is reboot your system. If you have a laptop that you actually almost never reboot, you close the screen, it goes into hibernation or sleep, and then you open it up, it comes back up. Things sometimes can get reboot it. Well, now watch out, of course. Some of you who have 24 web pages open in your browser and 100 applications in the bottom. When you reboot, you can lose them up. But close everything down, reboot your computer, come back up, and it may work. Experience from other students says that fixes it. So good. If you're having problems with Java, the 2 of you contact me and we'll resolve that. Okay, the metric quiz. Okay. Somebody confessed they didn't do it. A couple of them were confused as to how to do it. And then there were a couple that worked on it. And I know I emailed several people valiantly tried to get this to work and just had difficulties. I did send some hints out earlier. I think it was last night. So take a look at the hints. And then about the same number of people who got other things running got Zap to work. Zap is a little bit more challenging. Yes, actually, only one soul has got it installed, but can't seem to get it to obey. That had sometimes been my problem. I can get it there, it just doesn't always do what I want it to do. And then people haven't got to Zap yet. Yeah. Well, those of you who haven't got to Zap yet, the assignment that's due next week requires you to know Zap, or actually requires you to run Zap. Now, it should run, it's pretty standard. Just set it up to run with WebGoat this time, and it should work. So give that a shot. And of course, if you're having trouble, send me an email. If necessary, we can Zoom together and talk about it. Okay. All right. So yes, again, the assignment is due noon on Tuesday next week. I will be picking up the stuff that you did this week, last week for the other assignment and the hack into the metric quiz, and pretty grades out there. There are a lot of 95s, and as soon as I get that done, I'll send out some notes. Maybe next week we'll just talk about how that worked. A lot of people had ideas that didn't work real well for how to fix it, and we'll talk about that. Maybe that question was a little difficult since we're just beginning on the course. Okay, but that's it for today. I will see you next Tuesday. Assignments due Tuesday at noon. So